The odds ratio is one of the main ways to quantify how strongly the presence of a variable is associated with the presence or absence of another variable in a given population. Imagine that I want to study the association between thrombosis and pulmonary embolism in patients with PICS. I will be dividing my result into 4 categories: negative pulmonary embolism and negative thrombosis, positive pulmonary embolism and negative thrombosis, negative pulmonary embolism and positive thrombosis, and finally, positive pulmonary embolism and positive thrombosis. I will calculate the ratio of each category like this. To calculate the odds of a positive pulmonary embolism in the absence of a thrombosis, I need to divide 0.06 by 0.94. This will give me an odd of 0.06. To calculate the odds of a positive pulmonary embolism in the presence of a thrombosis, I need to divide 0.10 by 0.90. This will give me an odd of 0.11. The odd ratio is the ratio between both numbers. In my example, 0.11 divided by 0.06, which gives 1.85. The odd ratio indicates that there is correlation, not causation. An odds ratio greater than 1 indicates an increased risk. An odd ratio smaller than 1 indicates a reduction of risk. In my example, my odds ratio is 1.85. This number, taken alone, means that there is 1.85 times more risk of having a pulmonary embolism when there is a thrombosis. The odd ratio cannot be interpreted without the confidence interval. It represents the level of uncertainty of the odds ratio. For example, if the odds ratio includes number 1, it indicates that there is no correlation. In this graph, we see a confidence interval of 0.78 to 2.92. In this second graph, with the same odds ratio, the confidence interval does not include number 1. It varies between 1.39 and 2.31, and this will be statistically significant.